I'm Preetha Chatterjee. In this presentation, I will describe our work on automatic extraction of opinion-based Q&A from online developer chats. At the first place, why do we want to mine question and answers from developer chats? So one of the applications of mining question and answers could be towards building conversational artificial intelligence. So recent efforts in research in the field of software engineering is towards building virtual assistants that can help in specific software development tasks, such as pair programming, bug repair, etc. Now, as we all know that the early versions of virtual assistants, for example, Siri or Cortana, focused on short task-oriented dialogues, such as play a music, right? But then the more sophisticated versions deliver coherent and engaging interactions. And to do that, they often integrate specialized instances for one task. So for example, they could combine dialogue management, opinion mining, question answering to do one task. So in this work here, we focus on investigating two of these specialized instances, that is opinion mining and question answering. And this is done towards building an opinion providing virtual assistants for software engineers. So as a first step here, we extract opinion-based question and answers from chats, and we call this system ChatIO. And the corpus generated from ChatIO could be used towards building this kind of virtual assistants. To design an automatic system, we actually formulated two subproblems. The first part focuses on automatically identifying the opinion asking questions, while the second part focuses on automatically extracting the answers to those questions. So now let's see an overview of ChatIO. So how the intermediate modules connect to each other. So first we start with using a supervised machine learning algorithm for chat disentanglement. Basically, this is to extract out separate conversations from an interleaved chat history that is necessary for analysis. Now we move on to the opinion asking based question identification. So here we use a linguistic heuristic based technique to identify these questions. So let's see an example here. So this is the same question that we saw on the last slide. And here I show you the heuristics that we used to automatically identify this question. So basically all our heuristics are a combination of part of speech tags and a set of keywords. So I will move on to the next part of ChatIO, which is the answer extraction part. So here at this point, we have already identified the question. Next, we consider each message or utterance in a conversation as a candidate answer. And we use the question and each of the utterances to make separate question and answer pairs. At the first step, we used a software engineering customized word embedding model, which has been trained on the recent Stack Overflow corpus and create joint Q&A embeddings. So these embeddings are then fed as an input to the convolutional neural network, where we learn about the semantics of the question and answer pair. And the output of the CNN is then fed as an input to a bidirectional LSTM, after which we finally make the answer prediction. We basically investigate two research questions. We divide it in two parts. The first part focuses on evaluating the automatic opinion asking question identification, while the next research question is on evaluating the answer extraction module. We used conversations from two different developer chat platforms called Slack and IRC, and we used 6 different types of programming communities. So the goal set, again, the human annotated data set for the question identification consists of 400 conversations across all these communities. And our answer extraction module is a little bit larger and consists of 2,000 conversations from these communities. So I'll start with talking about the first research question. So here we are evaluating the automatic opinion asking question identification. So we use 3 different types of sentiment analysis tools. The first one is SentiStrength SE, which is customized for software-related text. And then we also use 2 off-the-shelf sentiment analysis tools called Core NLP and NLTK. And then we also compare ChatIO to another pattern-based technique called DECA. So this has been proposed to identify opinion asking questions in developer emails. So now I'll show you our the table which shows our evaluation results in terms of each of our evaluation measures for all the techniques that we saw. So from the figures here in the table, we observe that the sentiment analysis tools overall show high recall with low precision. And interestingly, for SentiStrength SE, actually the precision and recall is both low. We also see the other pattern-based technique called DECA shows a perfect precision of 1, and that is because it identified 1 true instance in the dataset, and therefore it has very high precision but a low recall. And finally, we observed that ChatIO achieves overall better precision and F measure when compared to all the other techniques. Now, I will move on to the next research question. So here, this is about identifying, evaluating the answer extraction module of ChatIO, and we compare it with 3 heuristic-based techniques, one machine learning-based technique and another deep learning-based technique. So I'll explain them one by one. So the first heuristic-based technique is location. So based on the intuition here that a question would be immediately answered, we take or extract the utterance next to a question as a potential answer. Next, to model the content similarity between a question and answer, we compare the average word embedding between them, and if it passes a certain threshold, we consider that utterance to be a possible answer. The next one is sentiment. So here the intuition is that the answers to opinion asking questions might exhibit sentiment, and therefore we extract any utterance exhibiting sentiment as a possible answer. Now, we combine all these heuristics as features and use a simple machine learning based algorithm as SVM to predict the answers. And finally, we also compare ChatIO with another deep learning-based technique, which was designed to extract answers from a non-software related Q&A forum. So in this slide here, I show you the evaluation measures for each of the techniques that I discussed, and the measures are also shown for each of the programming communities that we investigated. So here, we first talk about the heuristic-based. So we see among the 3 heuristic-based techniques, location exhibits significantly better than the content or sentiment. And this is because content and sentiment often marks follow-up questions as false positives. Then we see that compared to the other techniques, ChatIO achieves highest overall precision and recall. And another interesting observation here is that although ChatIO performs consistently across all the communities, there is a drop in one of the communities, the orange one, for closure. And on a further manual analysis, we saw that in this community, answers are often provided as just code segments. There was no English text or not much text to it, and we couldn't model that semantic link, and therefore it was difficult to automatically extract those answers. In summary, ChatIO automatically identifies opinion asking questions using a heuristic pattern-based technique and answers using a deep learning-based architecture. And this work could advance mining of information from developer chats towards building several applications, such as building specialized software engineering virtual assistants. The question and answer pairs that we extract from ChatIO could also be used towards generating facts. It could be used for tool support for building recommendation systems, and the corpus could also be used toward understanding developer behavior and collaboration in sharing opinions.